So today we're going to look at pages 4 and 5 of the Chapter 9 study guide. Okay, just to kind of recap on what we've done so far in Chapter 9, I'm going to scroll all the way up here. Okay, so you see here that we have looked at quadratic and absolute value graphs. So we've learned about how to shift them, what their characteristics are, what it looks like in the equation when it's shifted left or right, up or down, if it gets more narrow or if it gets wider. So we've experimented with a lot of these things, and if you don't remember them, you can go ahead and plug these into Desmos and compare them to your parent graph, which the parent graph is f of x equals x squared, or you could say it's y equals x squared, right? F of x is just y. So just keep that in mind, okay? And then this is the vertex form, all right? So this tells us the vertex here is h, excuse me, h comma k. I don't think I'm going to edit that sneeze out. Sorry, guys. It takes too much time to edit it out. So h comma k is the vertex, all right? The h also tells us if we move left or right from the parent graph, and the k tells us if we move up or down from the parent graph. The a here tells us if we get wider or skinnier, and if it's a negative a, then it's flipped upside down. So there's a few things that you definitely want to review about what we did before spring break. And then here's the vertex form of absolute value graphs. So they have very similar characteristics, almost the same, except for instead of this quantity squared, it is the absolute value of x minus h instead of x minus h squared. Okay. Now we talked about different forms that we've seen throughout the past, honestly, like throughout the past 4 to 5 months now at this point, if not longer than that. But we've seen standard form of a quadratic, that gives us the y-intercept. We've seen factored form. Whenever it's factored, we can quickly find the x-intercepts using the zero product property. And then now we know vertex form, we can quickly find the vertex, all right? So you definitely had some Khan Academies assigned to practice that. So if you did not practice those Khan Academies, please make sure that you do those. All right, so we did some of these practice problems. And again, these are all in the study guide videos I've done, so make sure you rewatch them if you've totally forgotten what we've learned so far in Chapter 9. All right, so here we're going to review writing inequality statements. Okay, so we're going to talk about what it means to solve systems of equations and writing and solving quadratic inequalities as well. So let's just review a few things. So this symbol here, that is the less than symbol. And then whenever you throw a line under it, that is less than or equal to. Okay? So if I had x is less than or equal to 5, I know that my x value is any number below 5, or it could also be equal to 5. Okay? So that's just a little example. And so then also if we have the greater than, that one is greater than or equal to. Okay, I'm just going to copy this. Whoa, that's not what I wanted. So this one will be greater than or equal to. Sorry, definitely squeezing it. Okay, greater than or equal to. And then of course we have the equal to, that would be an equality sign. But here we're going to be looking at inequalities. So here we go. So it says given two segments or two intervals, we need to write two inequality statements. Okay, so first let's just focus on this area right here. Okay. I'm not sure why the dot is not exactly on this. Let's assume that this dot here is on the -10 just to make it easy, and that this dot here is on the 20. Okay, it's an open dot, so that's really important, all right? An open dot is whenever it's less than or greater than, okay? So it'd be open dot here, open dot here, all right? And then whenever, sorry guys, whenever it's a closed dot, I'm really glad I'm recording this because my throat's already hurting and I haven't even been talking for that long. That spring break will do to you. Is whenever it's less than or equal to or greater than or equal to is the closed dot, okay? So right here in part A, we see here the open dot at -10. And then we have a bunch of values over here to the left. So this is telling us that our x could be anything that is less than -10, because here, if we go further back, we'll get to -20, -30, and so on. And all those numbers are less than -10. And since it's an open dot, it is not equal to -10. Whoops. This one is only less than -10. All right, so this area here, that arrow with the open dot, represents this inequality. X is less than -10. So now, knowing that, I want you to try to write this one here on your own. Give it a shot. This one's a little bit more difficult, just because it's a little hard to see. You know here how I wrote the 10, the -10 first, if we wrote the 20, and then the x over here, it's a little bit difficult to read that out loud. So here we want to talk about, okay, all of our possible x values. They're all to the right of 20, which means they're getting bigger. So 30, 40, 50, and so on, right? We can keep on going. So this means that all of my x values are greater than 20. And they're not greater than or equal to because this here is not a closed dot. This is what it would look like if it were a closed dot, but it is not, okay? So that line there tells me x is greater than 20. So here we have two options. So it's x is less than -10 or x is greater than 20. And this would be your two answers, or your two inequality statements. Okay, so either x is less than -10 or x is greater than 20. All right, so over here, given one segment interval, we want to just write one inequality statement. Now, technically, you could write two, and you would have to have an and sign in there, but it's much easier to just write one inequality statement for these. So you see here we do have closed dots, so that means that we're working with greater than or equal to or less than or equal to, okay, with the closed dots there. So we're focusing that our x value, whatever our variable is, or whatever the value is that we're missing, is in between. It looks like it's at -5. It's like right in between the -6 and -4, and at 1, right in between the 0 and the 2. So our x value is somewhere in between those two numbers. However, since it's a closed dot, it could also be equal to the 1. So x is less than or equal to 1, and x is greater than or equal to -5. So you see how I have the opening of that little angle, or I guess the alligator, if you remember from elementary school. The alligator's mouth is going towards the x because x is bigger than the -5, okay? If you were to say this out loud, it would be written as x is greater than -5, or you can even say it as -5 is less than or equal to x, and x is less than or equal to 1. So that would tell you that the x value is in between -5 and a +1. So I encourage you to pause this video and try out part B on your own. So I did A and C first just because those were the two different examples. Now I want you to try out part B and part D on your own. So you must pause this video because I'm going to go through with them, but please pause the video and try it on your own first. Okay, so let's just focus on this arrow here. It's an open dot, so it's either going to be less than or the greater than sign, no equal to for this guy. This one's nice. I always like writing these because we can actually write it in the logical order. All the x's are over here somewhere, so they're all less than this -2 here. So that is the statement for that arrow. X is less than -2. Now over here, Let's do this color, let's do purple. Okay, this is at the 1 and it's a closed dot. Okay, so that means that it is less than or equal to or greater than or equal to. So all these numbers over here are just getting bigger than 1, so that means x is greater than or equal to 1. You can also see down below here how it says if inequality symbols are less than or greater than, should not draw those lines there, those are bad. The points are not included and are shown on number line with an open point. Okay. So that also summarizes what I've been saying over and over again. And then here it says if inequality symbols are less than or equal to or greater than or equal to, the points are included and are shown on the number line with a closed point. I should just say with a closed point, not with an closed, no, with a closed point. Okay. So since there were two separate segments or two separate intervals, so x is less than -2 or x is greater than or equal to 1, right? Just like that. Okay, by the way, this was the final inequality statement up there, so that one should be boxed. That one's good to go. Okay, so here's another one. So here I'm at 1. The x is somewhere in between 1 and 6. Now we have to pay attention to if it's a closed dot or an open dot. So I see that this one right here is an open dot. So x is greater than 1. Okay, all these values, 2, 3, 4, 5, 6, those are all numbers that are greater than 1. So that's why the opening again is facing the x. 1 is less than x because x is greater than 1. And then I see over here that this is a closed dot on the 6. So that means x is less than or equal to the 6 there. All right, so this is just telling us that that x is between 1 and 6, but it is not equal to 1, and it could be equal to 6. So that's why it's so important to know your signs and what they mean. All right, but that one is all done. All right, so solving quadratic inequalities on a number line. So this one, we're going to be plugging in points and testing them. There are not many practices on, or there's actually no practices that I could find on quadratic inequalities. So it's really important that you really pay attention to this video because there's no practices to go along with it, okay? So here are the steps. So here we go. We have 2x squared plus 7x is less than 15. The first step is to rewrite as an equation instead of an inequality. So let's go and do that. So we have 2x squared plus 7x equals 15. All right, so it says here, find both solutions for x to the quadratic equation by factoring and using zero product property. I could also complete the square or use the quadratic formula, but let's see if it's factorable first, just because that's usually the easiest way. So we're going to start to solve. First, I need this written in standard form, equal to 0. So we have 2x squared plus 7x minus 15 equals 0. So now I'm just going to see if it is factorable. So 2x squared times -15 is -30x squared. And then the 7x here goes on the bottom. So if I'm trying to find factors that multiply to 30, actually multiply to -30, right? So keep that in mind, and add to 7. 1 times 30, 2 times 15, 3 times 10, 5 times 6. And looks like 3 and 10 are going to be the two factors. But which one of those needs to be negative to give me a positive 7x? So if I have 10x and 3x, which one of these needs to be negative if we add them together to get 7x? Hopefully you said the 3x must be negative, okay? So this is nice, it is factorable. So that means we can set up an area model and factor this equation here. I don't really need that big of an area model, let me make it a little bit smaller. All right, so The top left is the ax squared term, and across from that diagonally is negative 15, because that's the c term. Our factors, we got 10x and negative 3x. I'm just going to zoom in on this part here just for now. So to factor them, please pause the video and do this on your own because you should be able to do it. So give it a shot. Okay, hopefully you did it. So 2x squared and 10x, the GCF is 2x. Between negative 3x and negative 15, that GCF should be negative 3. They both have a negative and they're both divisible by 3. So 2x times what equals 2x squared? I'd say 2x times x is 2x squared. 2x times 5 is 10x. And use one double check. Is 5 times negative 3 negative 15? It is, right? So that's good. So if you double checked everything by multiplying it, you would see that your work was correct. Okay, so we're not done yet. We have to find both solutions for x. So we need to solve for x now. Now that we have the factors, we can set each of them equal to 0 because this is now saying 2x minus 3 times x plus 5 equals 0. Because all we did was take this and factor it, it's still equal to 0 whenever we're trying to find the x-intercepts. So here I have 2x minus 3 equals 0 and x plus 5 equals 0. Okay, I'm going to take all of these and make them just a little bit smaller because I know I'm going to need some room to write some more work. All right, so now we have to solve for x. So I'm going to add 3 to both sides here. I'm going to have 2x equals 3. Divide both sides by 2. 3 halves is just 1.5. Over here, it's a single step, subtract 5 from both sides. We're going to get x equals negative 5. Okay, so now we want to set up a number line. So I see here that we go all the way back to negative 5. So we can start there and then just kind of work our way up and hope that we can fit it all in one shot. Yeah, I think we'll be able to. Okay, so we always want to go from like negative infinity to positive infinity. So it's always the negatives to the positives because you want to make sure that it's a number line, so you're going in increasing order from left to right. So one of my points is right here, negative 5. Okay, and then the other point I got is 1.5. So what I'm going to do is just add a little dash in between the 1 and the 2, and that is 1.5. Okay, so let me see here. Yeah, so that one would be 2, 2, 2. There we go. All right, so it says plot these solutions or boundary points. So those two are our boundary points is what those are called. And we have to test each region. So we don't know where the arrows are going to go. We have no idea, right? So they're either going to go out like this, or they're going to go towards each other and connect in the middle. So then their solution is somewhere in here. So we have to try to figure out what it's going to be. So here's what we want to do is draw little lines because we're going to test each section. So we have 3 sections. Let's call it section A, B, and C, just for purposes of me talking about each section. So section A, I can test any number that is less than negative 5. So let's test x equals negative 6 for section A. And let's see what ends up happening. So my original equation is what I need to be testing. So it's right here. 2x squared plus 7x is less than 15. Okay, so I'm just going to take a copy of this for myself so you guys know exactly where I got it from. Okay, so this is where we're going to test it at. Which, by the way, this is, we're going to test each region. We're going to call them A, B, and C. Okay, just because that's how I want to test them. All right, So here, what we do is we plug in the -6 for each of the x values in the equation. And we're going to see, is it less than 15? That's what we're trying to figure out, okay? So first things first is exponent. So if you're following PEMDAS, right, our order of operations, we simplify inside parentheses first, but these are only a single number, so we don't have anything to simplify there. But the exponent, -6 squared, we have 2 times 36, 7, or actually here, I'll save that for the next step. All right, so we did the exponents, now it's time for multiplication. 2 times 36 is 72. 7 times -6 is -42. And then we just have to less than 15. So it's still like a big old question mark. We don't know, right? 72 minus 42 is 30. Is that less than 15? No. No. Does not work. Okay? But we still want to test all of the others. So we know that it is not going to go to the left this way. It will not go that way. So now here, let's go ahead and test a number that is in the middle. Honestly, 0 is the easiest number to test. So anytime I have a section with 0, I always test 0. So let's test x equals 0. So our original equation again was 2x squared plus 7x less than 15. So we have 2 times 0 squared plus 7 times 0 less than 15. 0 squared is just 0. 2 times 0, again, these are all question marks, right? 2 times 0 is 0 plus 0. Is 0 less than 15? Yes, it is. All right, so I know that I will have a shading in here. Okay, just to be extra safe, let's go ahead and test something in section C. All right, I'm just going to test my lowest whole number, which is 2. That is over here in section C. All right, so even though you guys don't see this -6 over here on the line, we know that this is an arrow, so it's going to be all the possible numbers below -5. So that's how I knew I could test -6, just in case that confused anybody. So here we're going to test 2, x equals 2. And let's see if it's true or not. Whoops. Sorry guys, I have the sniffles tonight, as usual. All right, so we have 2 times 2 for x plus 7 times 2 for x is less than 15. I don't know, let's see. 2 squared is 4. 2 times 4 is 8, plus 7 times 2, I don't know what just happened with my voice. You guys would totally make fun of me in person. You know who you are. 8 plus 14 is 22, less than 15. Is that true? No. Right? 22 is not less than 15. Not true. Okay? So I know it's not going to be this side. It will be in the middle, and it's not going to be this side. All right? So now I can actually write an inequality statement. That's the whole point to get to this point. Or that's the whole point. That's the process to get to this point, right? So to write the inequality statement, I'm going to just take a quick little snippet of our number line. Okay, just to limit the writing that's happening over there. So here's our number line that we have. All right, so we know that x is in between the -5 and the 1.5. Now we know that it is equal to -5 and 1.5. So here it's going to be -5 is less than or equal to x, and 1.5 is less than or I'm sorry, x is less than or equal to 1.5. Okay, so this is saying x is greater than or equal to -5, and x is less than or equal to 1.5. All right. And if you guys wanted proof for this here, what you could do is test test x equals -5. So this would be 2 times -5 squared plus 7 times -5 less than 15. Basically, we want to see, is it equal to 15? Is it equal to 15? So here we'd get 2 times 25 plus 7 times -5, 50 minus 35. Is 50 minus 35 15? Yes, it is. So that's why it's less than or equal to there. And then if we plug in 1.5, you will also get that each of the sides are equal. So it's 15 equals 15. And you can totally check that out in a calculator if you'd like. I just don't feel like multiplying out decimals right now, but you can test x equals 1.5 in calculator. And if you get 15, which you should, then you know why it's less than or equal to 1.5 and not just less than. Okay? So with these, it's a lot of testing, all right? And I know this has been long so far, but let's go and do one last one where we're also going to graph it, okay? All right, here we go. So we have x squared plus 2x minus 8 is greater than 0. First, let's go ahead and solve it, okay? So just to clarify, this is our equation. I want to see if it's factorable so I can solve for some x-intercepts. So I have x squared plus 2x minus 8 equals 0. Let's see if it's factorable. So I'm rewriting it as an equation. Now I'm going to find both solutions for x. X squared times -8 is -8x squared. This 2x goes in the bottom of that diamond. So if I want to try to find 8, 1 times 8, 2 times 4, somehow I can combine 2x and 4x to multiply to -8x squared and add to positive 2x. So go ahead and try that out on your own. Pause the video and try to factor out the rest of it completely. Find the x's. Okay, get all the way down to this point on your own. You can do it. I know you can. Pause the video. All right, hopefully you paused it. Okay, so if I have 4x and 2x, which of these needs to be negative to give me a positive 2x when they're combined? Well, if I had negative 4x plus 2x, that would be negative 2x. So the 2x in this case needs to be the negative. Okay, so now if we set up our area model, x squared needs to be in the top left, -8 bottom right, and then we have our factors 4x and negative 2x that need to be diagonal from each other as well in the area model. So now go ahead and factor this, and please do this on your own if you have not done it already. Pause the video and try it out. Okay, so here x squared and 4x, GCF is x. This GCF is -2, x and positive 4. So this is all review, and that's why I'm going this quickly. So now we have x minus 2 times x plus 4 equals 0. Well, if we split them up now using the zero product property, x minus 2 equals 0 and x plus 4 equals 0, we can now solve for x. So add 2 to both sides, x equals 2. Subtract 4 from both sides, x equals -4. Okay. All right, so now we know our x-intercepts. So I'm going to go and plot those. So we know x equals +2 and x equals -4. All right, so now the y-intercept, okay, the y-intercept is going to be -8 because it's in standard form. So anytime we have the c term, that is our y-intercept. So this one's going to be at 0, -8. 0, -8. Now there's a few different ways to find the vertex. The vertex is right in between our x-intercepts. So our vertex is usually h, k. Okay, let's just keep it like that. Now this is the x-coordinate, and the k is the y-coordinate. Now, to find the h, what you can do is you can take the x-intercepts, right? So the x-intercepts, and add them together, and then divide them by 2. You will get the x-coordinate of the vertex, because the vertex is right in the middle of the x-intercepts. So here we have 2, and then plus a -4. Just scoot these over to the left a little bit. There we go. Okay, 2 plus -4 is -2. Over 2 is -1. So now I know that the x-coordinate, I realize I used the wrong color, should have been red. The x-coordinate is just the middle between the x-intercepts. So here I know it's going to be -1. So it's going to be somewhere along what we call the line of symmetry here at -1. And you see that's right in between my x-intercepts. So 1, 2, 3 to the line of symmetry. 1, 2, 3 to the line of symmetry. So it's perfect. Now to find what the y-coordinate is of that, you need to, you might be able to notice that right here, where the 8 is, it's going to be somewhere down here, but we don't know exactly where until we solve for it. You could not just guess, okay? So to solve for it, right, so to solve for the y-coordinate of the vertex, okay, what you need to do is plug in your x-coordinate into the equation. So our equation here was x squared plus 2x minus 8 equals 0, okay? We don't need the equal part. We just need to plug it in for the x's. So the x's, I'm going to put parentheses where they are, and then I'm plugging in the x-coordinate -1. That is my h. Okay, so now if we start to simplify this, -1 squared is 1, 2 times -1 is -2 minus 8. 1 minus 2 is -1 minus 8 is -9. That one is really pretty. -9, that is our k. Okay, so you can always do that, or you can rewrite the entire equation into vertex form by completing the square. But normally students like to do this. They find the midpoint right here between the x-intercepts, and then they plug that in to the equation to get the y-coordinate. So we have -1, -9. That is our vertex. And now you see that since it's symmetrical, we know that this point here is also going to be on our parabola, just like this one here is. Okay? So now I can kind of just sketch. Oh, wait a minute. I almost forgot. We have to pay attention to if it was less than or greater than, because that is a dashed line, or if it was less than or equal to or greater than or equal to, because that is a solid line. Okay, solid line. So here, let me just take a little snippet of this. Oops. This was our original equation. Hold on. There we go. All right, so which one of these is it going to be? If it was a greater than sign, it's going to be a dashed line. Okay, so whenever we draw this parabola, we have to have dashes through the line. This is where it curves and then comes back up. Okay. All right, I was just making sure that I didn't miss anything. So now it says, okay, shade the region that satisfies the original inequality. We shade inside the parabola if it's less than or equal to, and outside if it's greater than or equal to. However, if I'm remembering right, I think we had a few instances where this rule did not always apply. So here's what I want you guys to always do. Test the point 0, 0. Okay? So we're going to test 0, 0 and determine, is it true? So you see here how it's a 0 there? I want that to be a y. Sorry. So let's see here. So if we had x squared plus 2x minus 8 is is greater than 0. Okay. Oh yeah, I think this one was actually the one where it threw us off a little bit. Oh no, this one would have been right. Greater than. Yeah, okay, so let's see here. So we want to know. So here 0, 0 is inside of the parabola. So if it's true, then we're going to shade right there inside the parabola. So here we go. I'm going to go and plug in 0 for x. And then this is technically, that should have been a y, I'm sorry. Minus 8, and then a 0 for the y. So 0 squared is 0, plus 2 times 0 is plus 0, minus 8. Is that greater than 0? Well, 0 plus 0 minus 8 is just negative 8. Is that greater than 0? Is negative 8 greater than 0? No. So, shade outside. Because you see here the 0, 0 is inside of this parabola, but since it was not true, we need to shade only the outside of the parabola. These are all the possible solutions that would work in that inequality. The inequality x squared plus 2x minus 8 is greater than 0. So it's technically greater than y, right? So right here, I wish that what this should have said and what it will say on a test is greater than y, not 0. Okay, you put the 0 in to solve for the x-intercepts. But really, this would have been our original equation, or inequality. Should have had a y there instead of the 0. So that looks pretty messy. Most of the time this rule does work, but I remember I had students who ran into the instance, and I can't remember if it was just because we made a mistake on that problem or not, but just use this with caution. You can always test the point 0, 0 pretty quickly because you see how most of the terms zero out anyway, and then you're really only looking at the y-intercept in that 0, and okay, is the y-intercept greater than or less than the 0, you know? So I would always test 0, 0 just to be sure. All right, well, I think that does it. So we just wanted to get through pages 4 and 5. I know this was a longer video and I do apologize, but since you don't have any practice on this, I wanted to make sure that you really did get as much info as you could through the video. Okay, so the next video